Welcome to Bite-Size Data Science. In the last video, we ended our use case with finding a set of intersections that had the highest number of accidents. For this, we used the Dbscan algorithm. As a reminder, Dbscan stands for Density-Based Spatial Clustering of Applications with Noise. Let's explore Dbscan further by getting into a notebook. I am using the IBM Watson Studio environment to run my notebook. If you are interested, you can find a link in the description on how to create a free account on that platform. Links to the notebook I'm using here are also available in the description. Let's skip the part where we read the data, since it is the same as in video 76. We pick it up at the visualization of the accident using scatter plots. As mentioned in the previous video, the scatter plots gives us an impression of where the clusters could be. Using the Dbscan algorithms, we define the distance between neighboring accidents to be within a distance of 0.00015 degrees, and a cluster had to have at least 18 core samples. The distance in degrees is applied to longitude and latitude. We then displayed the center of the top 20 clusters on the map. Getting an insight on the important intersections lead to one set of solutions. Could we get different insights and solutions if we're using a larger distance? Let's try different distances, starting with a city block. Interestingly enough, Wikipedia gives us the size of a city block in Chicago. We can't have an exact size since the Earth is an ellipsoid, so we are using an approximation. We use the new distance and keep the same number of density samples. We end up with 518 clusters and 28,005 noise points. This means we removed 58% of the accidents to get to our clusters. Since we increased the distance by a factor of 8, should we increase the distance by the same factor? By doubling to 36, we reduce the number of clusters to 105, and the noise points now represent 87% of the dataset. Let's take a look at a visualization of the result. At first blush, it appears that the clusters still represent intersections. If we zoom in to see the polygons representing the clusters, we can confirm that some of them appear to cover roughly a city block. Let's see if we can get different insights if we increase the distance to around half a mile based on the latitudinal distance. Using this new distance and a min samples of 144, we end up with 13 clusters and only 40% of the accidents were considered noise. It's worth taking a look at the clusters on a map. Surprisingly, we see clusters within clusters. Looking at the clusters, it's obvious it's not what we want. We need to try other min samples values. Let's summarize the findings, starting with the block distance. We saw that using a min sample of 18, we ended up with 511 clusters and eliminated 58% of the accidents. Increasing the min samples to 36 gives us 103 clusters and removes 87% of the accidents. If we continue to increase the min samples, we reduce the number of clusters and increase the noise percentage. In fact, if we were to use a min samples of 144, we'd end up with one cluster and 99.7% noise. Overall, the progression does not seem to be very different from the intersection size. It is quite different when we go to half a mile. At mid-samples 144, we see some major overlap and only 40% of noise points. When we increase to 216, we still have overlaps and the noise increased to 38.7%. Even at 288, we appear to have a little bit of overlap, even with an increase of noise point to 71.6%. With min samples at 360, we have 4 clusters and 85.7% noise. With these results, I believe we can conclude that Dbscan is effective when we can eliminate at least 70% of the accidents as noise. This way, we can focus on the important areas. Increasing the distance gave us different insights that can lead to different solutions from the intersection insights. For example, it could mean increased police patrol in some areas to remind people to be more careful. Of course, more analysis needs to be done to get to the proper conclusion. See you next time on Bite-Size Data Science. And don't forget to subscribe.